Okay, today we're going to be working with tangent and tangent approximations, right? So everyone knows that at least what people tell you is that tangent of x equals sine of x, sine of x over cosine of x. But in reality, nobody wants to work with trig functions because that's boring. So in reality, tangent of x is very approximately close to x to the third, right? And here's a little visual proof of that, right? Like right here, it's basically the same thing. Like for all intents and purposes, it's the same thing. So, what we can do instead of memorizing our unit circle, like who wants to do that, is we can just approximate tangent with x to the third, right? So for tangent of 4, right? Nobody knows what tangent of 4 is, let's be honest. So we're just going to say tangent is like approximately equal to x to the third. So tangent of 4, approximately equal to x to the third, or 4 to the third, right? So everyone knows what 4 to the third is, equals 64. So that equals, not approximately, equals 64, okay? You can use your calculator if you want to, but nobody uses calculators. And this also works in calculus. It's a very important part of calculus, actually. You'll end up learning that if you take more like advanced calculus courses, because it's very, very important for very difficult integrals, especially ones that require a lot of thinking, which you're probably not used to, but it's okay. Everyone will get there someday. So let's work out this integral right here. Okay, so we have this integral, right? Nobody knows what the integral of tan x is, especially when it's multiplied with x. So let's just substitute this out. Tangent substitution, that's what they call it in high-level calculus, but you probably won't know that for a long time. So the integral of x, tangent x, that's just equal to x times x to the third. Of course, we got the integral and then the dx to know that we're integrating with respect to x. So obviously, this becomes a lot easier because it's literally just this. It's x to the fourth dx, right? And this, bro, we all know this. It's just the power rule, so minus 1 over, 4 plus 1 over 4 plus 1. It's literally that easy. So the general antiderivative, the general antiderivative, or the integral, high-level people use those words interchangeably, it's okay. So that means our integral, or general antiderivative, is equal to x to the fifth over 5. Whoops. Oh my god. Let's just get rid of that. So that means we can just take this over there. Boom, that's our answer. It's that easy. Now, this is a definite integral, so it's not a general antiderivative. You could do a Riemann sum, but you probably don't know how to do that because you're not that advanced, but it's okay. So tangent of x, we know that's equal to x to the third, right? So that means we're just going to substitute that out and integrate. And of course, it's just the power rule, so we do plus 1 over 3 plus 1, and if you know what that is, write it in the comments, but I don't really know what it is. So we're going to have that. It's going to be x to the third plus 1 over 3 plus 1. But for this one, x is going to equal 4 minus, we'll just do this. Take this. We'll just throw in the 4 right there. Not sure what that value is, but it's okay because we can just assume that that the person that is like, when you put this on an exam, the teacher will assume that you're smart enough to do it because you know the steps, but you don't actually need to know what to do it. You know what I mean? So we're just gonna do that, and then 3 plus 1 over 3 plus 1. And then that is our answer. And nobody's going to fact check you on it because you'll know the tangent substitution. So people will just assume that, like, you were, like, you know, too smart to do it. Like, you didn't want to waste your time on solving that part out. You know what I mean? And that'll give us the value or the answer under the curve. Because that's what integration is if you didn't know. Well, that's about all I wanted to cover. Goodbye.